Welcome to Next Gen Manufacturing. Today, we're diving into a technology that is, well, it's quietly revolutionizing medicine from the inside out. It's this whole world of incredible precision that's changing patient care as we know it, creating these tiny medical marvels on a scale that's almost impossible to even imagine. I mean, think about it for a second. From the tiny screws holding bones together to really complex dental implants, the parts going inside our bodies are getting incredibly sophisticated, you know? They're smaller, they're stronger, and way more effective than ever before. So how are they actually made? That's the big question we're going to solve today.
It really all comes down to what you might call medicine's invisible engine. This is the unseen force that's driving some of the most important breakthroughs in modern healthcare, making surgery safer, and honestly, just making patient outcomes a whole lot better.
And that engine? It's called micromachining.
This is the answer to that question we just asked. It's where we get to see engineering happening right at the very edge of what seems possible, literally crafting the future of medicine one tiny part at a time.
So what exactly are we talking about here? Well, micromachining is basically the art and science of engineering incredibly small and complex components. It uses some seriously advanced machinery to create features that are so tiny they're measured in microns. And just to help you wrap your head around that scale, get this. We're talking about creating features that are smaller than the width of a single human hair. That level of precision is it's mind-boggling. And it's what allows for the creation of implants that can integrate almost seamlessly with the human body.
And the benefits here are just huge. First off, you get maximum precision, which is, absolutely critical for complicated medical parts that have to be perfect. Then, it's incredibly efficient. It cuts way down on material waste, which saves money. And finally, it's remarkably flexible. You can work with everything from advanced metals and ceramics to high-performance polymers.
Okay, so how is this actually done? Let's take a look inside the toolkit for this tiny tech and see how these ideas get turned into real, physical, life-saving devices.
It all starts with processes that probably sound familiar, just on a micro level. So, take drilling. This is a cornerstone used to create these teeny tiny, minuscule holes in things like advanced surgical tools or the orthopedic bone plates that help fractures heal just right.
Then you've got milling. And this isn't just about cutting, it's really about sculpting. Micromilling carves out these incredibly intricate, custom-fit surfaces that you'd need for, say, a dental implant that has to perfectly match a patient's anatomy, or for components used in really delicate spinal repair surgeries.
And finally, we have turning and threading. That's where you shape material as it spins to create things like the precise microscopic threads on an orthopedic screw. These processes are absolutely essential for making those tiny screws that hold us together, not to mention the secure connectors for vital tools like catheters.
But of course, making the perfect shape is really only half the battle. When you're putting something inside a person's body for years, maybe even for a lifetime, the material it's made from is just as critical as its design.
Yeah, the choice of material is so important. For instance, titanium is strong, it's biocompatible, and this is a big one, it's not magnetic, which is vital if a patient ever needs an MRI. You've got stainless steel, which is a go-to for surgical tools because it's tough and easy to sterilize. We also see advanced stuff like PEEK, a super strong yet lightweight plastic, and even ceramics, which are extremely hard and wear-resistant, perfect for long-lasting joint replacements.
So let's zoom back out for a minute. We've looked at the what and the how. Now let's talk about the why. How does all of this micro-level technology actually translate into better health and better outcomes for all of us?
In this technology, it goes way beyond just implants. Check this out. Micro-drilling allows us to create what are called labs on a chip. These are tiny devices that can run complex medical tests using just a single drop of fluid, maybe even right at a patient's bedside. The potential here for fast, accessible diagnostics is it's staggering.
So, the crucial point, the real takeaway, is this. Micromachining isn't just some small step forward, it's a fundamental shift. It is making healthcare more precise, it's making it less invasive for patients, and it's opening the door to revolutionary new technologies for diagnosing and treating diseases earlier and more effectively than we ever could before.
And all of this leaves us with a final, really powerful question. We are mastering the ability to engineer on a scale we could once only dream of. So the real question isn't just what we can build, but what we should build. As this technology keeps advancing, what big human challenges will we choose to solve next?